supposed to be routine, just another cold traveler brushing past our solar system, quietly following the same physics and the same expectations that astronomers applied to every comet before it. They named it 3I-LYRA, the third confirmed object to arrive here from another star. And at first, the discovery seemed ordinary. A faint dot, a predictable arc, a simple object visiting once and never returning. But then everything changed. As Lyra approached the orbit of Jupiter, the signals grew strange. Its glow flickered in ways no thermal model predicted. One night it brightened sharply, the next night it dimmed, almost as if the object couldn't decide what it was supposed to be. Astronomers compared it to watching a heartbeat that didn't match any known rhythm. A comet should brighten smoothly as sunlight vaporizes frozen gas, but Lyra wasn't following that script. They expected it to behave like 2I, Borisov, stable, predictable, textbook comet physics. Instead, Lyra behaved more like a distant echo of Oumuamua, the first interstellar visitor, famous for its strange acceleration and tumbling shape. But Lyra wasn't identical to either of them. It sat somewhere in the middle, familiar enough to recognize, unfamiliar enough to unsettle the models built to explain it. Brightness variations in comets usually come from dust, sublimation, or occasional jets of gas escaping through cracks. But the patterns from Lyra were too sharp, too sudden, too irregular. Some researchers suspected fragmenting ice. Others thought it might contain exotic ices unseen in our solar system materials that evaporate explosively when warmed. And a few wondered if Lyra's structure was porous or fragile, a sponge-like relic shaped by radiation during millions of years drifting between stars. But the most alarming discovery wasn't the brightness, it was the motion. As Lyra came closer, astronomers watched its trajectory very carefully. Interstellar objects move fast, far too fast to mistake. But small, consistent nudges appeared in the data, tiny pushes that were not caused by gravity. These effects were the same type that made Oumuamua so controversial. But with Lyra, they were becoming clearer, stronger, and more connected to its irregular brightening. Each time Lyra flickered in brightness, its path shifted just slightly, like a traveler being pushed off course by invisible hand. For the first time, scientists realized they weren't looking at a stable comet at all. They were watching something unstable, unpredictable, and perhaps even dissolving before it reached the inner solar system. This is why the region near Jupiter became so important. Not because Lyra was heading toward the planet, but because the lighting conditions were perfect for measurement. If the earlier anomalies were just observational errors, this was where they would disappear. But instead of calming down, Lyra became even more unpredictable. Its tail twisted against the solar wind, as if jets of gas were firing in directions no model could explain. Its brightness curve, the heartbeat of any comet, looked broken. One astronomer said, "It's like watching a snowball fall apart in slow motion, except the snowball came from another star." The theories multiplied. Was Lyra cracking open from internal pressure? Were pockets of ancient ices erupting as they thawed? Was the object already in the process of breaking apart? Or was it something more exotic, something shaped in a star system with chemistry we've never seen? Nobody had a confident answer. And that uncertainty made Lyra more important than anyone expected. Interstellar objects are time capsules. They carry the fingerprints of worlds we will never visit. Their chemical signatures reveal how other solar systems form. Their surface behavior shows how ice and dust survive the cold, dark emptiness between stars. And their structural weaknesses can reveal which materials endure cosmic radiation for millions of years. Lyra was delivering all of this at once. Every irregular flicker hinted at chemical differences. Every unexpected acceleration hinted at hidden jets of escaping gas. Every sudden dimming suggested collapsing dust or fragmenting pieces. And the deeper it moved into the inner solar system, the more dramatic the story became. By the time Lyra crossed the region near Jupiter, astronomers realized they might be witnessing something that won't survive its own journey. Lyra might not make it past the Sunday. It could disintegrate entirely, leaving only dust, gas, and the memories recorded in early observations. But even if it does break apart, it already taught researchers a crucial lesson. Interstellar visitors don't follow rules. They don't fit categories. They don't repeat the behaviors of the ones that came before. Oumuamua was strange. Borisov was normal. Lyra is unpredictable. 3 objects, 3 different stories, and each one rewrites the understanding of what forms around distant suns. The mystery of 3I-LYRA is still unfolding. New observations continue to arrive, each one more revealing than the last. And no matter how this ends, whether Lyra breaks apart or survives the trip around the sun, it has already expanded the picture of how diverse the galaxy truly is. Because out there, beyond our star, countless objects like Lyra drift silently through the dark, some stable, some fragile, some unlike anything we have ever seen. And every once in a while, one passes close enough to remind us just how little we truly understand.